This video is on applications using quadratic equations. If you're in my course, you can, see this packet and you should print it for yourself as we go through these examples. Or you could write out the examples, pause it, write it out, and then answer it in your notebook if you prefer to do it that way. But we're going to go through a variety of different types of examples where quadratic equations are used. So far you've seen different ways of solving quadratic equations. We solved them by factoring, we solved them by complete the square, we also solved them by the quadratic formula. So making sure that those are all different ways you can solve a quadratic equation. Here we'll use some of those methods as we go through and answer these questions. So for the first part, we got a company projects that its annual profit, which we're calling P of t, that's just the name of the function. The name of the function is P of the variable t in thousands of dollars. So the profit is in thousands of dollars, and that's important to know. Over the first 6 years of operations is approximated by P of t equals, we got 1.2 t squared plus 4t minus 8, where t is the number of years completed. So t is years, you input a year, you get out profit in thousands of dollars. That's what this function really tells us. So part A says estimate the profit or loss of the company after the first year. So after the first year, that's telling us something specific. T is the number of years completed. So this is when t equals 1 year. So for part A of this question, what they're really asking you to do is to find P of 1, right? Find the profit at 1 year, right? P of t is the profit in thousands of dollars for some time t. We're saying this is the profit after 1 year. So P of 1 just means sub 1 into this function. And we end up with 1.2 times 1 squared. Make sure you write that with the parentheses around the 1. Plus 4 times 1 minus 8. And simplifying this, you would have 1.2 times 1 squared. Well, 1 squared is just 1. 1.2 times that would just be 1.2. Plus 4 times 1 is 4 minus 8. And you can do this on a calculator. We've got 1.2 plus 4 minus 8, and I get negative 2.8. So if we have negative 2.8 here, all right, what does that mean? What were we looking for? We're looking for to estimate the profit, right? So we put in the time, what we get out is the profit after that time. Now if I got a negative number for profit, that's really a loss, all right? And when we talk about negative 2.8, what's that measured in? Well, profit's measured in thousands of dollars. This is negative 2.8 $1,000. Make sure you know the units, right? Units are important, you should be including them. So we have $2.8 thousand. Now, let's say I wanted to actually get that in just dollars instead of thousands of dollars. Really all you got to do is take the negative 2.8 and multiply it by 1,000, which gives you negative 2,800. All right, so just so you see it, negative 2.8 times 1,000 will give us just dollars, which gives us negative 2,800. What are the units on this? Well, this is dollars. So what's that mean? Well, if it's negative, that means that your profit isn't a profit at all, it's a loss, right, after the first year. So the company, just as a sentence, you should write it for yourself too. The company lost $2,800 after the first year. Right, that's what this tells us. All right, part B is very similar. Right, part B says estimate the profit or loss of the company after 6 years. So what's that telling you? It's telling you t equals 6. So for part B, all they're asking us to do is find P of 6, the profit after 6 years. And again, you're substituting in. So we have 1.2, right, we're substituting into our function, times t squared. T is now 6, so it's 6 squared. Make sure parentheses around the 6. Plus 4 times t, which is 6 now, so 4 times 6, minus 8. When you're doing this, make sure you follow your order of operations. So you should be doing the 6 squared first. It's 36. So you have 1.2 times 36 plus 4 times 6 minus 8 looking at each of these individually, 1.2 times 36 is 43.2, plus 4 times 6, which is 24, minus 8, and we'll just add those up. 43.2 plus 24 minus 8, we get 59.2. 59.2 what? Well, remember, profit was measured in thousands of dollars, so 59.2 $1,000. And if you remember what I said above, to get just dollars, you multiply by 1,000, right? So 59.2 times 1,000. And if you wanted to just do it on your calculator quick, you know, it's 59,200. And this is dollars. Now, this is a positive number. What does a positive number mean in this case? Well, a positive number means that it's a profit. All right, so in this case, it's a profit. So let's write a sentence that describes this. All right, so the profit for the company after the first 6 years, right, because that's the time they told us, right, and that's what we subbed in for time, is $59,200. All right, and then the last question, it says estimate the time needed to break even. Make sure you know what it means to say break even. Break even means you don't take a profit or a loss, right? So it's, you know, break even, you know, exactly the amount that you started with, right? You didn't lose any, you didn't gain any. So when I say to break even, that means the profit is 0. When it says estimate the time, we're trying to find t. So you're not going to sub in 0 for t because we're trying to find the time, right? We're trying to estimate the time. You're going to sub in 0 for the p of t side of the equation, the profit. The profit will be 0, right, when you break even, right? So it's telling you, you know, p of t is equal to 0. The y value is equal to 0, in other words. So we'll do part C down here. So what I'm really going to do is I'm going to set p of t equal to 0. Right, that's what it means to break even, the profit 0, which really means that I'm going to have, you know, 0 is equal to 1.2 t squared plus 4t minus 8, right? All I'm doing is I'm taking the function here and setting it equal to 0. I'm trying to find the time when profit is 0. That's what it means to break even. Okay, well, how do I solve this? Well, you could try to solve it by factoring, but it's kind of difficult if you don't have integer values. So we can use one of our other methods, either complete the square or the quadratic formula. I'm going to use the quadratic formula. I'll use QF for short for quadratic formula. I won't write out the whole formula, but we'll say it out loud together. So we're solving for t, so let's use t equals. You know, if this variable was x, we typically write x equals, but make sure you have the variable equals. And remember how the formula is. It's negative b. So remember, this is a, b, and c, the coefficients here. So negative b, well, b is 4, so it'll be negative 4 plus or minus the square root of b squared, so of 4 squared, minus 4 times a, which is 1.2, times c, which is negative 8. You should know how to use this formula already. It's all over. Make sure the whole thing is over, and it should show this way. 2 times a, so 2 times 1.2. And what we're going to do is simplify this, right? So simplifying this formula, I end up with negative 4 plus or minus the square root of 4 squared is 16. Negative 4 times 1.2 times negative 8. Well, negative times a negative is going to make this a positive. If you do this, 4 times 1.2 times 8, we end up with 38.4. So it's plus 38.4 because the negative times the negative made it a positive. It's all over 2 times 1.2, which is 2.4. You can multiply it in the calculator if you're not sure. Okay, so then this equals, continuing on with this simplification, we got negative 4 plus or minus square root of 16 plus 38.4 gives us 54.4. So 54.4 over 2.4. And, we're using an approximation here. So typically, I'd say leave the exact values. But because we're doing an applied problem, we want to use an approximation. So let's approximate the square root of 54.4. It's not a perfect square. So we have -4 plus or minus, taking the square root on our calculator, 54.4. We got 7.3756. I'll just use 2 decimals, so 7.38. So plus or minus 7.38 all over 2.4. And remember, I'm doing this because it's an application problem and I want to figure out, a number of years. Typically I'll tell you what to round to. In this case I didn't write it on here, but at the end of the problem we'll round to 1 decimal place, so that's why I'm going to use 2 throughout, just to make sure that we have it. So how many answers is this? Well, this is actually 2 answers, remember. So this really means that t is equal to, we get -4 plus 7.38 divided by 2.4, or you get -4 minus 7.38 divided by 2.4. Right, so it's 2 answers. And we should evaluate each of the answers. For the first one, if we have -4 plus 7.38, it's 3.38, and then we're going to divide that by 2.4. And we get 1.400, or 1.408333. So we're going to round this. Now I said the end will round just to 1 decimal place, so 1.4. Remember, this is t. T is what? Well, t is, right, the time in years. Right, so number of years completed. So this is 1.4 years. The other value down here, we get -4 minus 7.38. It's going to be a -11.38 divided by 2.4. Right, so -4 minus 7.38, just so you see it. -11.38 divided by 2.4. And this comes to -4.74, so we'll say -4.7. What's this supposed to be measured in? Well, time, right? We're finding time when we break even. That's years, but does that make sense to have negative years? You can't go back in the past to break even. So we reject this, right? Because, time can't be negative, right? So make sure you know that. And you should say reject. You can't just show me both answers. So when do we break even? We break even after 1.4 years. So the company breaks even, meaning profit is 0. That's what we did. After 1.4 years. So, we talked about, how to use a function here. We also talked about using the quadratic formula to solve an equation. The next example is very similar to what we just did. The premise is a little different, but it's the same type of question in terms of they're using a quadratic equation to describe a scenario. So let's take a look at that. So in this example, you're on a roof of a 60-foot tall building and throwing a ball upward into the air. All right? The height of the ball in feet above the ground can be modeled by the function h of t equals -16t squared plus 30t plus 60, where t is the number of seconds after the ball is thrown. All right, so let's just make sure we understand the function. T is the number of seconds after the ball is thrown, so t is the time, right? H of t, right, is the height of the ball at time t, right, above the ground, right? So it's the height in feet above the ground at time t of the ball. So you sub in a time, and you'll get a height out. All right, t is the number of seconds after the ball is thrown. So part A says, how long after you throw the ball will it be 25 feet above the ground? Well, what's this thing? When I say how long, what am I trying to find? How long, you're trying to find time. Sometimes people get confused by this. You have to make sure you know what you're trying to find. So I'm trying to find time, so you shouldn't be substituting in for it. You're trying to solve for it. All right, when the ball is 25 feet above the ground, what it's really saying is that we want h of t, right, the height, to equal 25 feet, right? So h of t is 25. So I'm really substituting into this left side of this formula with just 25, right? The whole h of t, remember, that's just a description of the height at time t, is going to be 25. So for part A, right, we're going to have 25 the height at time t is equal to negative 16t squared plus 30t plus 60. And now we're trying to solve this for t, remember, that's the goal, right? How long? Well, when you solve a quadratic equation, first thing you should do is get in the standard form, get one side equal to 0, so we'll subtract 25 from each side. So I end up with 0 equals negative 16t squared plus 30t plus 60 minus 25 is going to be a positive 35. Once I've done that, I want to solve this either by factoring using quadratic formula. This doesn't look like it factors easily if it does factor, so let's try to use quadratic formula just because we're doing something we learned in this section. Again, I won't write out the quadratic formula, you should already know it, but remember, A is negative 16, B will be 30, and C is 35, right? It comes from the coefficients. Make sure you have this written in descending order. So quadratic formula is negative B, so it's negative 30 plus or minus the square root of B squared will be as 30, so 30 squared minus 4 times A is negative 16, don't lose the sign, times C, which is 35, and this whole thing is over 2 times A, so 2 times negative 16. And now we want to simplify it, right? So t is time, we're trying to find the time. Simplifying this, we get t equals, we have negative 30 plus or minus the square root of 30 squared, which is 900 if you do that on your calculator. Negative 4 times negative 16 times 35. I know it's going to be a positive because a negative times a negative will make it positive. 4 times 16 times 35 gives us 2240. And this is all over negative 32, right? 2 times negative 16 is negative 32. So we get t equals, simplifying just inside the radical here, we got negative 30 plus or minus 900 plus 2240 is going to be 3140. So plus or minus the square root of 3140 over negative 32. And similar to the last problem, we can see if 3140 is a perfect square to try to simplify it. But if not, we still want to get, a time here. So we want to, do an approximation. On a test or quiz, I would tell you what to approximate to if I wanted you to approximate. But here, if I take the square root of 3140, let's see what that comes to. We got 56.035, so 56.04 is what I'll use. So t equals negative 30 plus or minus 56.04 all over negative 32. And that will approximate this, it's two answers. Making sure you check both of them and see which one we're going to need. So negative 30 plus 56.04 over negative 32 is one answer. Negative 30 minus 56.04 over negative 32 is the other answer. So the negative 30 plus 56.04, if you're looking at just this first one here, we know it's going to be 26.04 divided by negative 32, right? If I do negative 30 plus 56.04, it comes out to 26.04 over negative 32. Now, something you should notice right away, you have a positive divided by a negative. Now, you had to calculate the numerator first, but now that we did that, we have a positive number divided by a negative number. We know this is going to come out negative. If I know it's going to come out negative and we're talking about time, right away you can say reject, right? You could divide it and find what the answer is, but it doesn't matter. The truth is that you're rejecting this answer because you can't have a negative time, right? So as soon as you know it's going to be negative, you can reject that answer. This answer is going to be positive over here. Negative 30 minus 56.04 is negative 86.04 over negative 32. So the reason we know it's positive is that this is a negative divided by a negative at this point. So it comes out to positive. Now you should divide this, 86.04 divided by 32. Notice I know the sign negative or negatives make it positive, so I don't have to show it on my calculator. I have 2.688. We'll round to one decimal place now because it's our final answer. The 8 will round the 6 up to a 7, so this will be 2.7. Remember what we found? We found time. Time was measured in what here? Number of seconds. Make sure you have units. This is 2.7 seconds. So the ball will be, right, 25 feet above the ground. That's what we found when the height was 25, right? That's what we're asked for at 2.7 seconds. All right, so a lot of times when you do these problems, you'll have to reject an answer. Not always, but sometimes you will, depending on the premise. Let's take a look at the next one. So the next example here, letter B, it says, how long after you throw the ball will it hit the ground? Well, when it hits the ground, right, how long, again, you're still trying to find the time. But when it hits the ground, what's the height? Well, h of t is the height of the ball in feet above the ground. So if you actually hit the ground, the height is 0, right? You're going to be on the ground. So the height is 0. So what's really asking you is, when does h of t equal 0? So you're doing the same thing we did in the first problem, except for now h of t is going to be 0 here. So 0 is the height, and we're trying to find the time, how long. So we keep t as it is. So we got negative 16t squared plus 30t plus 60. Make sure you're substituting into the same formula we have here with 0 on the side for the height, and you're using negative 16t squared plus 30t plus 60. And you might want to try this on your own. You might be able to solve it now. It's very similar to the first part. When you're looking at this, it's a quadratic function or quadratic equation. You might want to try to solve it by factoring, but you don't have to. Something I would point out, though, is that this all has a GCF here you could factor out of 2. Now, if you don't factor out the GCF, you'll still get the same answer in the end. But let's factor it out just so you can see what happens. So I'm going to factor out GCF of 2, and the first term's negative. I'm going to take out a negative 2. So I'm going to take out negative 2, which leaves me inside the parentheses with 8t squared. And then remember, the signs are going to change. 30t dividing out the negative 2 makes us negative 15t. A positive 60 factoring out the negative 2 makes us a negative 30. All right, and this whole thing, equals 0. I guess I already have the equal 0 on that side, so I don't have to write it again. So now if I wanted to solve this, I'd try to factor this. It may not factor nicely, and if it doesn't, then you'd have to use another form that we know. So I'm going to use the quadratic formula here. But if it factored nicely and you could see it right away, you would want to factor this down and solve just like we did in the past. But here I'll use the quadratic formula. Now, when I use the quadratic formula, I'm only going to use it on the inside of this. You could use it on the whole thing at the very beginning, but once you solve this, you remember, if you're solving by factoring, you would factor these down so each term or each factor that had a variable equal to 0. Negative 2 doesn't have any bearing on that, right? Negative 2 can never be 0. So if you just look at the inside of this and solve for t here, you'll be working with smaller numbers, which makes it a little easier to finish the problem. Now, if you did it using the original problem, that's okay. I'm going to use this piece in here for my quadratic formula. I'm solving for t. So when I talk about a, b, and c, I'm using them in here, right? A is 8, b is negative 15, c is negative 30. So we start with negative b, so it's negative 15 plus or minus the square root of b squared. So it's negative 15 squared. Make sure you have that negative 15 in parentheses, because that negative being on the inside parentheses matters. All right, minus 4 times a, which is 8, all right, times c, which is negative 30. And this is all over 2 times a, which is 8. Make sure you're using the correct equation. Let's simplify it. So we end up with t equals, this is negative 15, which just makes it positive 15, plus or minus. This is the square root of negative 15 squared. We know a negative times a negative makes it a positive. 15 squared is 225. If you don't know it, you can use your calculator. Just make sure you understand that. It should be a positive number, right? Negative squared makes it positive. If you don't type it correctly in your calculator, you might not get the right answer there. A negative 4 times 8 times negative 30. The negative times the negative makes us a positive. 4 times 8 times 30. We'll do it on here just so you see it. Oh, 4 times 8 times 30. We get 960, so 225 plus 960. And this is all divided by 16 here. 2 times 8 is 16. And we'll simplify this. This is 15 plus or minus the square root of the 225 plus 960 will give us what, 1185. So square root of 1185 over 16. And then we'll do what we did before, which is we'll approximate this. Comes out to a nice perfect square. That's nice, but the square root of 1185 I don't think is a perfect square. So the square root of 1185, we get 34.42. Plus or minus 34.42. This is all over 16. And you got to think about what you have here. Well, we have two answers. All right, we have 15 plus 34.42 over 16, and you've got 15 minus 34.42 over 16. 15 plus 34.42, that's going to end up being 49.42 over 16. So positive divided by a positive is going to be positive. Let's divide it. 49.42 divided by 16. I end up with 3.08875, so 3.1. We'll round to one decimal place, so 3.1, and that is time, remember, so it's seconds, 3.1 seconds. Over here, don't automatically think that you reject it. Make sure you actually at least do a calculation to determine that. 15 minus 34.42, it's going to be negative. That's the first thing you should notice. If you do it, 15 minus 34.42, you probably can see it. We got negative 19.42 over 16. A negative over a positive, again, this is going to be a negative value. If it's negative, remember, you can reject it. So I don't even care what the number comes out to, because I know I don't have negative time. That doesn't make sense. So after 3.1 seconds, the ball would hit the ground. That's what we found here, right? That's what they asked us to find. How long after you throw the ball will it hit the ground? So this equation, right, tells us when the ball will hit the ground. If you set 0 in for the height, that's the height at the ground, right? The height above the ground is 0 when you hit the ground. And that's what we did, and that's how we got 3.1 seconds. And then the last part of this says, what is the height of the ball after 2 seconds? Now, the height of the ball, it means we're trying to find the height, right? This question here, what is the height? So we're trying to find h of t. We don't know. Right? After 2 seconds, well, really we're saying h of, you should write it as h of 2. Right? What is h of 2? The height at 2 seconds. So that means you're going to sub in 2 everywhere you see a t, and then figure out what the height is at that point. So, well, you see, we're looking for the height at 2 seconds. And all I'm doing is substituting 2 in everywhere I see a t in this formula. So we got negative 16 times 2 squared, plus we had 30 times 2, and then plus 60. And we're going to evaluate this, right? This is the height at 2 seconds. You sub in a time of 2 seconds, you're going to get the height out. So remember, follow the order of operations. The 2 gets squared first. We got negative 16 times 4, plus 30 times 2, we know is 60, plus 60. Negative 16 times 4 is negative 64. You can do that on your calculator if you're not sure. Plus 60 plus 60. And so this equals, if you were to add this up, negative 64 plus 60 plus 60. And we get 56. So this is 56. What did we find? Well, we found the height at 2 seconds. What was height measured in? The height of the ball is in feet above the ground. So this is 56 feet. So at 2 seconds, the height of the ball will be 56 feet above the ground. It's important you have units on this. It's important you know what you're finding when. A lot of times people get these confused. Make sure you're looking at the question. If it says how long, you're looking for the time, so you shouldn't be substituting in for it. If it says what's the height, that means you should be substituting for the time to find the height. So hopefully those 2 examples help see some applications of quadratic equations. In the next examples, in the next video, we'll look at application problems where you derive the equation yourself.